So first I'm just going to go into a couple things that problem solving strategies that I'm going to take into my classroom that I learned this past semester and the semesters past. So one of the biggest takeaways that I learned is the power of letting students choose how they solve a problem. So not just teaching standard algorithm, which also made me wonder, is there even a standard algorithm? I know Joan says in class that other countries have different strategies that are more effective, more efficient, and who are we as teachers to tell students you can only solve it this one way if they don't even understand it that way? So I think just really allowing students to solve problems in whatever way makes most sense to them, as long as they understand why they're doing the certain steps they are doing. So I'm going to encourage students to use pictures, relational numbers, estimating numbers, and making friendly or easier numbers, problem solving strategies like that I learned in class that I think are very important, especially for elementary age students to know how to use. And then some strategies that I have learned and find the most effective for myself. I think the biggest one is the area model. I'm really glad I learned this in the beginning of the semester, because actually in my last Block 3 field experience, it was 4th grade, so they all pretty much were using the area model. Only a few of them were actually using standard algorithms. So it just proved how many more students understood the area model much more than trying to memorize in the standard algorithm what number to multiply next, where do I carry over, where do I put a 0 in, place value, things like that. It just really made it easier when they broke up the two numbers into more friendly numbers and then multiplied those and then added them up to get the total or the answer. I think that the visual of having the area model and seeing that it's one length multiplied by another length, and you're finding the total area that it's covering, makes it much easier to understand, and then also allows them to relate it to concepts like area. Another strategy that I would use a lot and never had before and found super interesting was the easier numbers strategy, turning numbers that may not be so friendly, or I would possibly have to be borrowing or carrying, things like that, just making those easier friendly numbers that maybe start in a 0 or 5 that I'm more familiar with, made it so much easier, and I had never thought of that ever, and so I thought that was really interesting and beneficial for my future students to be taught. The number line, so during subtraction problems, using a number line to visualize that you're trying to find the distance between two numbers, and if you want to make them friendly numbers, then you'll just be moving both of the numbers, because you're still trying to find the same distance between, you're not changing it less or more. So yeah, just making it friendly numbers, but making sure you're moving along the number line together. I thought that was a really good visual that I understood a lot. And then also using visuals for fraction problems, especially when multiplying or dividing by 1/2. I thought that helped a lot, and it made it way easier for me to visually see that what we were doing. So I will definitely be bringing that into my future classroom. The use of manipulatives is a very, very beneficial thing, especially when you're introducing maybe a new concept to students and allowing them to physically touch something and see it in person. I think is a super good way to start a lesson. My manipulative that I used in the fair was Pentominoes, so that was a great tool for upper grades, working on either they could do perimeter or conceptual spatial reasoning, so how certain shapes fit together, things like that, or comparing perimeters. It worked really well with that. I decided for the final to look into Serena and Tessa's activity with attribute blocks. I chose this because they said it would work well with 1st grade, and that's actually the grade I'll be student teaching with next semester. So I thought it would be good for me to get familiar with it and have some activities in mind that I could possibly teach next semester. So the attribute blocks help students better because they could physically touch and see the different shapes, colors, sizes, number of sides, things like that. And I don't think without the blocks, it would be much harder for the students to fully grasp the concept. And if they were just told, like, oh, a square has this many sides, a triangle has this many, or square has this many angles, triangle has this many angles, I think it's much more beneficial for them to actually be seeing the two different shapes and all the multiple shapes, comparing them to one another. It's definitely more beneficial to have the actual attribute blocks there, and they're able to recognize patterns and build a stronger foundation of noticing characteristics of different shapes, and then building on to that for more complex characteristics that they learn later on in their math career. So their original activity had students first discuss with a partner the different attributes that they noticed and characteristics they noticed about the blocks, and then after it said the teacher would guide students in making groups to put similar blocks and characterized blocks together, which I think it was a really good lesson. It made sense, and it was definitely a lesson that I would teach in my first grade classroom. I think maybe something that I would change about it is I think I would first distribute the attribute blocks, like the set, to each student, and I would have them categorize them into groups themselves just to see what each student does, and try to see their thinking and their reasoning, and then I would have them have a discussion with maybe a partner or a small group to defend why they chose to separate groups into specifics, categories. I think that would be a really good way for them to just be able to explain their reasoning of why they chose to do that, and then also see how other students chose to separate it and get another perspective. So yeah, I think it was a great activity. Both activities I would teach in my future classroom. After looking at the maestros, I then looked at after looking at the manipulatives, I then looked at the maestros, and my maestro was math anxiety, which I think was very beneficial because although I would say I never really had math anxiety growing up, so I didn't know much about it, it was really good for me to research and find more out about it, so I'm better able to help my future students who will have math anxiety, how to ease them and make them feel more confident and comfortable in solving math problems, and also some stereotypes that may come along with math anxiety. I think that was just very beneficial for me to research myself. The maestro that I chose to look more into for the final was the No Math Tricks presentation. So the questions for that, if I had a parent that was upset that I was telling students not to use math tricks because the parents said it worked for them, I think I would just explain to them that math tricks focus on shortcuts rather than actually understanding why the math works and understanding what steps you're doing, which I think will just limit their ability to solve harder problems in the future if they're not able to do this. If they're not able to understand what they're doing and why they're doing, they're not going to be able to build onto those concepts and those ideas because they're only memorizing certain steps, and they don't actually know why or how they're solving it. So to convince the parent, 3 ways to convince the parent that math tricks will or can be harmful to their student in the long run. I think the first one is just explaining that using math tricks will limit the student's math flexibility, so they won't be able. They're only used to solving a certain type of problem, and once they're given a problem that maybe is in a different context or is using triple digit numbers, things like that, or is just more complex, they're not going to be able to understand how to do it because they only know this one certain way, so they aren't flexible. I think that's one good reason not to use math tricks. The second, I would say, is it just gives students a bad understanding of the concept. They really don't know the concept because they're just doing a routine thing, like to solve the problem. They really have no idea what's actually going on or why the math works. So, yeah, they just won't have a good grip or concept of it. I think lastly, the third one is the student will struggle in future math classes. The math will get harder and shortcuts won't help. They need a good grasp of the foundational skills that they're learning in these early years so they can build off that and learn new ideas. They're never going to be able to excel and learn harder math concepts if they don't actually know what they're doing or why they're doing it. They're just following a set of steps. Yeah, so I thought the no math tricks presentation was really good. Another thing I'll be bringing into my own classroom is the influence and understanding the influence of my own attitudes about math. Although I did really enjoy math growing up, I know that not all my students will, and that all my students will come to me with previous math experiences, good or bad. So just reminding my students that we need to have a growth mindset and there is no such thing as a math person. Everybody can succeed in math, and that math will be hard and we can do hard things. We will get through it. Just emphasizing the importance of making mistakes. Making mistakes shows that your brain is growing, that you're learning. It's a part of the problem solving process. Another big thing with mistakes is allowing the students to know that I, the teacher, will also be making mistakes in the future, and just letting them know, whether that's in a math problem or just in the general classroom if I made a mistake, that everybody makes mistakes and it's okay. It's just a sign of growth. So I think that was something really important. Then going into CGI, super important to include into your classroom. So cognitive guided instruction, letting students just develop their own mathematical thinking and problem solving process. Just letting their previous existing knowledge of math guide their problem solving process. Which reminded me of something we read in one of the articles, and it said that procedural skills do not need to happen before students actually solve problems. So you don't need to teach those steps or how to solve that problem. You can give students a problem and they can interpret it and try to figure out on their own and use previous skills that they've learned to go through the problem solving process. And in a Fenema article that we read, it had said students in a CGI classroom actually felt more confident compared to another group of students not in a CGI classroom in their operational abilities, even though they had spent less time on mathematical procedures. So even though their teacher hadn't spent as much time on that procedures, they felt more confident in their abilities because they were given more time to just explore on their own and try to problem solve in their own way. So I just think that's super interesting and really important to include. I remember to say it takes time to have CGI incorporated into your classroom, but it is so much worth it because the students will definitely be more equipped and be able to understand more complex math problems and be able to explain that reasoning too. Another thing I want to incorporate in my classroom is small group and the importance of small group, because students have to justify their answer and the steps that they took to find the answer. So not only does it give other students different ways to see it, like, oh, they didn't know that you could solve it that way, but it makes those students defend their choices and explain to really show that they did understand the concept and the problem. So I think small groups is a great thing when having students solve math problems. Context in problem solving is another really important thing. So just the problems that we give our students to solve, if it's just a bunch of random numbers, or if it's a problem like 100 watermelons, why would students care about that and why would they want to understand it? So we just need to recognize students' identities and relate the problem to them, like including their names and problems or connecting to it personally. I think we also need to remember that students' background can affect how they perceive the context of a problem. I remember in one of the articles we read, it was about dividing pizza up evenly, and one of the students in the class was from a lower income family, and he couldn't understand the concept of why they would be dividing the pizza up evenly and not who needed it more or things like that. So just understanding your students' backgrounds and how they're going to interpret problems just shows how perspective changes everything in math. So understanding that and knowing that can relate to our social justice lesson plans also that we did in class. Like I said, I'm going to be student teaching in a first grade classroom next semester, so I chose to look at a social justice plan that I think Emma and maybe student Emma had made it, I know. And it was how freedom quilts were used to help slaves escape. So I was looking at shape specifically, and it was for first grade. And I chose this because I think that it would fit really well into a unit using that attribute lesson as well on shapes and characteristics of shapes. So yeah, that's why I chose it. I think learning about the shapes through enslaved people using quilts to communicate is just a way for students to connect to it more and realize that math is real world, or how it can connect to real world things, and it's much more important and can also relate to things like history. I think that's just really important for students to see and see it in different contexts. Something I would add to their lesson, or I think it also just, it made it much more important because it gave it context and it wasn't just a naked jumping jack problem like that. Something that I would add to their lesson is to incorporate more collaborative. They had students come up with their own quilts that had different shapes, but I think it'd be really cool if they all either put together a shape or put their quilt to make a big larger quilt in the class, just to show that your piece can be one part of a bigger thing. I think would be a really good thing to add to their lesson. I'm going to talk about assessment quick that I learned from this year. So I think I learned that there is going to be a lot of informal observational assessment happening in the classroom. So it's just super important for me to always be walking around, looking at how students solve problems, how they interact in a group, if they're able to explain their problem-solving process, things like that are just really important to assess, not just solely on formative assessments or quizzes, things like that. I think exit tickets are also a big thing that I want to incorporate into my classroom. Also using that to assess how my instruction is going and if I need to reteach something, because not many students understood that concept, is really important. So I'll be using exit tickets to not only see how the students are doing, but how well I taught that lesson. So overall, I just think this course has really impacted how I'm going to have my students operate my future classroom in the area of math. Like I said, I always enjoyed math, but I never thought that I would learn so much about how to teach math. I'm just very grateful for that, and I'm excited to personalize math for my students and reflect their identities into my teaching strategies. And I'm just very thankful for everything that you have taught me in math and life as well. So thank you.